Hello, aspiring network experts. Today we embark on a thrilling journey into the world of wide area networks, WANs, virtual private networks, VPNs, and IPsec. Wide area networks, WANs, serve as the foundation of modern networking by enabling the interconnection of geographically distant networks across long distances. They achieve this by utilizing the services of Internet Service Providers, ISPs, which facilitate seamless data transfer between remote locations. Let's explore some examples of WAN technologies and their applications. 1. Leased lines. Leased lines are dedicated point-to-point connections that provide a direct link between two locations. These connections offer consistent bandwidth and low latency, making them ideal for organizations that require a reliable and high-performance link between their branches or data centers. For instance, a multinational company may use leased lines to connect its headquarters in one country with regional offices in other countries. While leased lines deliver excellent performance, they can be expensive due to the exclusive nature of the connection. 2. MPLS, multi-protocol label switching. MPLS is a label-based routing technology that enhances the efficiency of traffic flow within a WAN. It works by assigning labels to packets, allowing routers to make forwarding decisions based on the labels rather than traditional IP routing. MPLS is well suited for large enterprises that require secure and reliable connections between their various locations. For example, a corporation with multiple offices worldwide may use MPLS to establish a private network that ensures efficient data transmission and consistent performance across their global infrastructure. 3. Metro Ethernet. Metro Ethernet is a cost-effective WAN technology that provides high-speed connections within metropolitan areas. It leverages Ethernet technology, which is commonly used in local area networks, LANs, and extends its capabilities to connect geographically close sites. Metro Ethernet is commonly used by businesses to link their branches within a city, facilitating fast and reliable data exchange. For instance, a retail chain with stores in different parts of a city can use Metro Ethernet to connect their stores to a central data center or cloud services for inventory management and sales data processing. To enable WAN connectivity, essential networking devices such as routers and switches play crucial roles in connecting and managing WAN links. Routers are responsible for directing traffic between different networks and determining the best path for data packets to reach their destinations. Switches, on the other hand, help create local network segments and allow devices within those segments to communicate efficiently. Together, these devices ensure that data flows smoothly between geographically distant networks, enabling seamless communication and data exchange on a global scale. Virtual private networks, VPNs, act as guardians of secure communications over public networks, like the Internet, by establishing encrypted tunnels to protect data transmission between remote users or branch offices and the central network. Let's explore the two main types of VPNs and some examples of their applications. 1. Site-to-site VPNs. Site-to-site VPNs, also known as network-to-network VPNs, connect entire networks or sites together, enabling seamless and secure communication between them. These VPNs are ideal for interconnecting branch offices or remote sites with a centralized main office. For example, a multinational company with offices in different countries may use a site-to-site VPN to create a unified network infrastructure, allowing employees in different locations to access shared resources, databases, and applications securely. All data transmitted between the interconnected sites is encrypted, ensuring confidentiality and integrity. 2. Remote access VPNs. Remote access VPNs, as the name suggests, enable individual users to securely connect to the central network from remote locations. These VPNs are essential for employees who work from home, travelers, or remote workers who need access to company resources while outside the physical office. For instance, a sales representative on a business trip can use a remote access VPN to securely access the company's intranet and customer data. Similarly, an employee working from home can connect to the central office network using a remote access VPN to collaborate with colleagues and access shared files. Remote access VPNs provide an encrypted tunnel for each user, ensuring that their data remains confidential and protected from unauthorized access. Various VPN protocols are used to establish these secure connections, depending on specific requirements and security considerations. 1. PPTP, Point-to-Point Tunneling Protocol. PPTP is one of the oldest and widely supported VPN protocols. It offers basic encryption and is relatively easy to set up, making it suitable for simple VPN deployments. However, due to security vulnerabilities, it is not recommended for sensitive or critical applications. 2. L2, TP/IPsec. Layer 2, tunneling protocol with IPsec. L2TP/IPsec combines the advantages of L2TP for tunneling with the security features of IPsec for encryption and data integrity. It provides a more secure connection compared to PPTP and is commonly used for establishing VPNs on various devices, including computers and mobile devices. 3. SSL/TLS, Secure Sockets Layer Transport Layer Security. SSL and its successor, TLS, are commonly used for securing web traffic. In the context of VPNs, SSL/TLS VPNs use web browsers and web-based applications as clients. They are user-friendly and do not require special software to be installed on the client's device, making them suitable for remote workers accessing company resources through a web portal. In summary, VPNs play a crucial role in securing communications over public networks, offering both site-to-site VPNs for connecting entire networks and remote access VPNs for individual users working remotely. The use of strong encryption and authentication protocols ensures that data remains confidential, integral, and authentic as it travels between connected entities. IPsec, Internet Protocol Security, is a powerful suite of protocols designed to ensure data security at the IP layer. It accomplishes this by providing data confidentiality, integrity, and authentication for VPN communications. IPsec consists of two main components, the authentication header, AH, and the encapsulating security payload, ESP. The AH provides authentication and integrity without encryption, ensuring that data remains unaltered during transmission. On the other hand, the ESP provides authentication, integrity, and encryption, guaranteeing both data confidentiality and secure communication. IPsec operates in two primary modes, transport mode and tunnel mode. Transport mode secures data between two endpoints and is commonly used for host-to-host communications within a VPN. In contrast, tunnel mode secures data between two gateways and is typically used for site-to-site VPNs, encrypting the entire IP packet for secure transmission. The applications of WANs, VPNs, and IPsec are vast and critical in today's networking landscape. They empower businesses to connect their branch offices seamlessly, enable remote workers to access the central network securely, and ensure that sensitive data is transmitted confidentially. Whether it's creating a virtual network infrastructure for a multinational corporation or providing secure remote access for a small business, the principles of WAN, VPN, and IPsec play pivotal roles in shaping modern networking solutions. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.